Alright guys, welcome to Calculus, day 1 essentially. We are going to work on the beginning section in the book just to refresh our memory on things that we've talked about in the past or something that I want to make sure we talk about before we really get into calculus. So before we get into that, we're going to start by looking at some basic graphs. And one of the basic graphs we're going to talk about is a linear graph, or where the graph of y is equal to x. And with linear graphs, these are just straight lines. We have seen lines that look like this, or lines that look like this, or lines that look like these. We've seen all of those different types of lines really with Math A when we worked with that. They don't always have to go through the origin, but that black line, my original one, is what's considered the parent function. So that's typically when we talk about a generic, we just talk about parent functions of where they start. So there's nothing going on to it. Next graph is a x squared, which is a parabola, or also referred to as a quadratic function. And again, we worked on this a little bit in B, a little bit with C. We can make them skinnier. We can flip them upside down. We can even move them off to the right. So again, any kind of quadratic. Now the difference between the first one and the second one is when I dealt with quadratics, I sometimes also had an x term in there, or I had a plus 3x or something. The way the graph is determined is based on the highest x value. So even if I had a plus 3x, the x squared wins out. Likewise, if I'm working on a cubic function and I have an x cubed, an x squared, and an x, that cubic function that cube still wins out and will have a shape of a cubic function. Next, we're going to go ahead and talk about finding the x and y intercepts, and that's where the graph hits the axes. So to determine that, if you think about that logically, let's talk about the x-intercept. The x-axis goes left and right. And anything that lies directly on that line is considered to be an intercept of the graph. Well, you're not going up and down any. So in order to determine what that's going to be, we're just going to let y be equal to 0. So I'm going to start off by saying that 0 is equal to x cubed minus 4x. Well, I need to get x values here. And since I have a cubic function, I should have 3 zeros. So the highest x value is the amount of zeros you should find, or in this case, intercepts. Zeros and intercepts mean the exact same thing, because it's set equal to 0. So what we're going to do is I'm going to start by taking out an x first. I'm going to factor out an x from each one. So that brings it down to an x squared minus 4. And if you recall, we can continue factoring that more, because we've seen this before. Okay. That's called the difference of perfect squares, or the difference of two squares. And if you recall your factoring skills, it means I can split that into two other parentheses, where they're able to bring down my x's to a single x. Instead of an x squared, I get an x. And just like with the x, we know the square root of 4 is 2. Now, if you notice, there's no plain old regular x in that boxed x squared plus 4. Because of that, that middle term is essentially 0. So what multiplies the negative 4 and adds to 0? Well, a positive 2 and a negative 2. Okay, so now that we've got all of our x's reduced down, we know that we can set everything equal to 0. So my first spot of x is equal to 0, set that equal. Then we have x plus 2 is equal to 0. and we have x minus 2 is equal to 0. Now, yes, x equals 0, which is what we want. We wanted an actual value for x is equal to. That's great. However, I'm not 100% done with that yet because I want to put these in a coordinate point system since we're talking about graphs. So I'm going to leave him alone, but I'm not going to circle him. If I go to the middle one, I don't have x by itself. I need to get x by itself, so I'm going to subtract 2 to both sides. Now I get x is equal to negative 2. Conversely, on the third example, or third 0, if I add 2 to both sides, I get x is equal to 2. And since we talked about these being in points, my answers are going to be in coordinate points. So when x is 0, y is 0. When x is negative 2, y is 0. And when x is 2, y is 0. And yes, they all have the same y value, but we already talked about that. Since we're letting that y be equal to 0 in the beginning, all of our y values should be the same. The only part different is our x's. Alright, well that's only where we hit the x-intercept or the x-axis. What about happens when we hit the y? Well again, logically, my y is just going to go up and down, so he's going to change, but x is going to stay the same. He's going to be at 0. So we're going to start this one by letting x be equal to 0. So I have y is equal to 0 cubed minus 4 times 0. And we know that 0 cubed is 0, and 4 times 0 is 0, and I wrote 4 as I said it. And 0 minus 0 is just 0. Nothing to really split apart here. So when x is 0, because we let x be 0, do that right there, I got an exit or an output or an answer of 0 as well. So my x-intercepts are 0, 0, negative 2, 0, and 2, 0. And my y-intercept is just 0, 0. Now, if you get a 0, 0 with your x's, logically you should get a 0, 0 with your y, because you have to have your y-intercept at some point, and if it hits at the origin, it's going to hit from both. Alright, we're going to jump this problem. We're not going to cross it out, we're going to jump over it. We're going to jump down to this guy. We're going to skip that first one, do not cross it out. We jump to the second problem. Alright, we are going to go ahead and find my x and y intercepts here. So to find the x-intercept, we talked about setting y equal to 0. So I have 0 is equal to x squared minus x minus 30. And I'm going to extend that a little bit so I don't end up writing over my face. So this case, this is what I want to do this example with you. I have an x term now. So we have a quadratic function. It's got a quadratic term, a linear term, and a constant term. I need to determine those x values that would make this 0. So I'm going to go ahead and start by factoring. Well, the only thing that will go to x squared is x times x. Now we need to think about what will multiply to a negative 30, add to a negative 1. Well, if you think about it, since I'm going to be adding essentially to a negative or subtracting to negative 1, I need two numbers right next to each other. So what will go into 30 that's right next to each other? 5 and 6. Now, if you notice, I didn't put any signs with them yet because I need to add to a negative 1. Well, which one's the bigger number? My 6 is. So since 6 is the bigger number, he's going to be negative. Then I split this problem like we did before. So I have x plus 5 equals 0, and x minus 6 is 0. I subtract 5 from both sides, and I get x is equal to negative 5. I add 6 to both sides, and I get x is equal to 6. So my x-intercepts are at negative 5, 0, and 6, 0. Let's take a look at our y-intercepts. Well, for y-intercept, we let x be 0. So I have y is equal to 0 squared minus 0 minus 30. 0 squared is 0 minus 30. So we get a negative 30 here. So my y-intercept in this case is 0, negative 30. If you notice, we did not have a 0, 0 in my x's, so because of that, I should assume or expect that my y-intercept will give me a different value, or in this case, 30. Now, I want you to pause the video. I want you to go back to the problem that we jumped over, and I want you to try this one on your own. When you're done, unpause the video and check your answers against mine. Hope we came to the same answers. So for my x-intercept, I got 0, 0, 3, 0, and negative 3, 0. For my y-intercept, I have 0, 0. Next, we're going to talk about the intersection of two lines. Essentially, what we're looking for here, where are these two lines going to meet? So we're going to look for my solution point. And since it's a point, we know we're going to have an x comma y. So we need to have both an x value and a y value. This works again with graphing, because if I were to graph these two lines, I want to see where they would cross each other. We're not going to actually graph them, though, because if you notice, they're not ready to graph. They're not in my y-intercept form. They're not y equals mx plus b. So we're going to go ahead and try and solve this based on elimination. Remember, with elimination, I want x's, x and x, y and y, constant, constant. Now, the idea here is to eliminate one of my variables, either the x or the y, whichever. I like to go with whatever is going to be smaller. If I notice, my x values are not the same number, nor are my y values. Well, that means I'm going to manipulate both functions in order to get to a common number. Just like when you think about fractions, you have to have a common denominator. I have to have a common number in order to cancel these out. Otherwise, I don't eliminate anything. Because if you think about it, eliminating 0, it's going to be going away. Well, if I look at 2 and 3, my closest number is 6. If I look at 5 and 4, my closest number is 20. I'm going to work with 6, because 6 is a little bit smaller. So in this case, I'm going to work with my x's. Now, if you also remember with elimination, I need to get it to 0. Right now, they're both positive. Positive plus positive is still going to be positive. It's not going to be 0. So I need a positive plus a negative with the same number in order to cancel out. So I'm going to go ahead and, just for funsies, multiply this top one by a negative 3 and this bottom one by a positive 2. The reason being is I'm trying to cancel out. I need a positive and a negative. Right now, they're both positive, so I need to give one of them a negative sign. Does it matter which one I make negative? No. I'm just picking the top one. It's the one I picked. So negative 3 times 2x is a negative 6x. Negative 3 times 5y is a negative 15y. And 10 times negative 3 is a negative 30. So what I've done there is multiplied everything by negative 3. Next, I'm going to do the bottom one. So I have 6x, because 2 times 3x, plus 8y is equal to a positive 24. Now what I'm going to do is I'm going to go ahead and add these two functions together. Negative 6 plus 6 cancels out, which is what we wanted to happen, goes to 0. Negative 15 plus 8 will give me a negative 7. And the y comes with, there's still regular y's. It's like a regular adding and subtracting of variables. You don't magically make it squared. We're not multiplying. We're just adding and subtracting. And then with my constants, I have a negative 30 plus 24, which will give me a negative 6. All right, I'm looking for x and y values. We talked about that at the beginning. If I scroll up here, I need a coordinate point. So I have something times y is equal to something, so I'm going to go ahead and get rid of that by dividing. So I'm going to divide both sides by a negative 7. I get y is equal to positive 6 over positive 7, because remember, negative over negative will turn positive. And that gives me as a decimal 0.86. Okay. Next, we're going to take that 0.86 and we're going to plug it into the original equation. Now, it doesn't matter which original equation we pick, we just need to pick one of them. First one, sounds great. Okay, so I have 2x, because I still don't know what x is, plus 5 times y. Now, we know what my y value is. It's that 0.86. And that's going to be equal to 10. So I'm going to go ahead and determine what my x value is. So I have 2x plus 4.3 is equal to 10. I'm going to go ahead and subtract 4.3, so I get 2x is equal to 5.7 divided by 2, and I get my x value is 2.86. So my final answer is 2.86, comma, 0.86. All right, now we're going to take a look at what happens when you have more than just regular linear functions. If you noticed, these are both linear. My x's were just to the first degree. Now we're getting into more complex points. So we have a we have a squared function here. We have a squared function down below. What we're going to do is, if you notice, they're both set equal to y here. My last example, they're set equal to constants. But since they're set equal to y, if this is equal to y and this is equal to y, then therefore, they must be equal to each other. And when they're equal to each other, I can manipulate it. I can add and subtract stuff. I can multiply and divide if I need to. Well, I see I have a quadratic over here, which means that maybe I might factor. So I want to try and set it equal to 0, because we can't factor until it's set equal to 0. So let's go ahead and move that stuff over. So I'm going to leave my x squared alone, because I like dealing with positive x squareds. I don't like dealing with negatives. I'm going to minus my x, so when he comes over, he's now negative. I have negative 3 plus 1 is a negative 2. Now I'm set equal to 0. So again, still thinking quadratics, we know we're going to have to factor. We said that earlier. We said we're going to have to factor, so we needed it equal to 0. We know x squared is equal to x times x, but what about negative 2? Negative 2, and we're going to add to a negative 1. Good, negative 2 times positive 1. So we know that I have x minus 2 is equal to 0, and I have x plus 1 is equal to 0. So my first x value is 2, and my second x value is negative 1. But we said in the slide before, we need a coordinate point. Well, last time, once I found one of them, in this case we found the y first, we just plugged it back in to determine what that x value would be. Same thing here. We're just going to plug both of these x values in to determine their y values. Doesn't matter which one I plug it into. I'm going to go ahead and do the easier of the two, because, I mean, I can square functions. It's not hard, but if they're supposed to both be equal, it shouldn't matter which function I plug it into. So I'm going to say my second one. So I have 2 minus 1, which is just 1. And just because I want to prove to you it doesn't matter, I'm going to plug it into the one above as well. So I have y is equal to 2 squared minus 3. And you know that 2 squared is 4, and I have 4 minus 3, which is, hey, look, the same y value. So it truly doesn't matter which one I plug it into. So my first point that they're going to meet at is going to be the 2, 1. Well, I still have another x value I found, so I have to find another point that they meet at. In this case, negative 1. So I have negative 1 minus 1. just -2. So they also meet at -1, -2. So in this example, it has 2 points of intersection because the highest x value is squared. All right, I want you to pause the video and I want to see what I want you to work through what your two answers are going to be, your 2 solution points. Once you finish, you can check your answers. So go ahead and pause that video. All right, guys, I got the following points. I got 2, 2, and -1, 5. If you have any questions, please feel free to contact me. There's your homework.